Dear student, in this lecture we are going to learn about computer networks and topic is multiple access protocol. Unit is link layer. So here we are discussed about multiple access protocol, and multiple access protocol is see, when a number of stations use a common link of communication system, we have to use a multiple access protocol in order to coordinate the access to common link. So there are so many algorithms used in the multiple access protocol, but and multiple access protocol also has some protocols here, and these are random access protocol, controlled access protocol, and channelization protocol, and these all protocols now further divided in some subparts like Aloha, CSMA, CSMA CD, CSMA CA, reservation, pooling, token passing, FDMA, TDMA, CDMA. So now we are discussed first Aloha. So Aloha divided in some parts. First is pure Aloha. Pure Aloha is nothing but it's a original Aloha, or we can say original Aloha is also known as a classical Aloha or a pure Aloha. In this Aloha, uh, when a number of subscriber here, and these subscriber operate independently of each other, and each subscriber has no knowledge that when the other subscriber will transmit their data packets. So Aloha neither coordinate medium access nor does it resolve the conflict of the MAC layer. So there is collision occur here, and if all these stations try to see resend their frames, after the time out of the frames will collide again. See, when station send its frame one time, and time will be outed, and after this, because every station does not know that other station has sent anything or not. So if timeout occur, and we will resend the frame, then collision will occur here. And prior Aloha dedicated that when the timeout period passes, each station wait a random amount of time before resending its frame, and the randomness will help avoid more collision. So there is some techniques through which we can control the collision. Pure Aloha has a second method to prevent congestion in the channel with retransmitting frames, and when the maximum retransmissions attempts, a station must give up, and the time out period is equal to the maximum possible round trip propagation delay, which is twice the amount of time required to send a frame between the two most widely separated stations here. So pure Aloha vulnerable time is 2 into TFR, and the maximum throughput S maximum is equals to 0.184. Fine. And this is a flow chart of pure Aloha when we start without sending. So if a station is start and it does not send any frame, then k equals to 0 that time, and when the frame is sended, wait time out is 2 into TP here, and acknowledgement received, if receiver from the receiver acknowledgement will received by a sender, then packet will successfully send it. But if acknowledgement is not received, then this frame is again, or this data packet will again resend it by the sender. So now we are moving on slotted Aloha, because pure Aloha, in pure Aloha collision is occur. So we are using slotted Aloha here, and slotted Aloha divided the time into slots of TFRs and force the station to send only at the beginning of the time slot. So the station is allowed to send only at the beginning of the synchronized time slot. If a station misses this moment, it must wait until the beginning of the next time slot. So some collision possibility is stopped here still, but still here some possibility of collision, because if two stations try to send at the beginning of the same time slot, that time collision is occur here. The slotted Aloha vulnerable time is TFR, and the throughput maximum is 0.368. Now we are moving on carrier sense multiple access protocol, because slotted aloha and pure aloha both have some disadvantages. So we are using carrier sense multiple access. And carrier sense multiple access, each station first listen to the medium or check the state of the medium before sending. That means if anybody want to send, firstly he check that some other person or some other station sending our data or not. See, this is non-persistence, and this is p persistence and one persistence, and these all time slot is divided here, and probability of outcome does not allow transmission is always greater than p. Now we are moving on, CSMA CD. In CSMA CD, CSMA, as you know, carrier sense multiple access, and CD is collision detection. At time, so in CSMA CD, we, as the name, we are detect about the collision. So at the time T1 station has executed its persistence procedures and start sending the bits of its frame. At time station C has not yet sensed the first bit sent by A, and station C executes its persistence procedures and start sending the bits in the frame, and station C detect a collision at the time T3. When it receives the first bit of A's frame, station C immediately abort this transmission. That means, see how it can work. See, here is four stations A, B, C, D, and when A is transmitted at bit at time t1, that time C does not know that A sent it any bit or not. But at time t3, at time t3 uh, at time t2, C send its packet, and at time t3 when collision is occur with A and C packets, the time C immediately abort its transmission, and only A's packet will pass. So station and when the station A detects collision at time t4, when it receives the first bit of C's frame, it's also immediately abort the transmission. And from transmission time is TFR is equals to 2 into TP, and maximum size of the frame is 10 Mbps. So I hope you understand this very well, and we are further continue in our next lecture. Thank you so much.